Assalamu alaikum and very good day. Today I'm happy to present our new invention, water desalination and purification chip in response to COVID-19 lockdown and water shortages. As all of us know, now the water shortages in all over the world, even before the pandemic crisis, is considered a serious problem many nations are suffering from. So it's expected by 2025 that the water shortages will be extremely high, up to 40% or more than 40% in many nations. Nowadays, the huge hit of the new pandemic, COVID-19, increases this problem because the accessibility for the freshwater resources start to be very limited due to the new regulations and procedures many nations adopted. And one of these procedures is lockdown and isolation of many cities and rural areas to stop the spread of the virus, and that limited the access of fresh water for millions of people. And in the future, it is expected that exactly the same thing will happen if a new pandemic starts. In the past few decades, several techniques were presented as an alternative technologies to secure fresh water. One of these techniques is desalination. Desalination of seawater proven to be an effective but expensive method to have fresh water from seawater due to the high power consumption or demand by this technology because of the presence of membranes that separate the salt from the seawater. You can see from here that the desalination technology was applied worldwide, especially you can see here in the Middle East, where there is a severe shortage of fresh water, and large number of the facilities are placed in this region of the world. Now, we can summarize the effect of COVID-19 pandemic on the freshwater production or freshwater accessibility by 5 points. First, as we said, accessibility. Second, availability. 3, isolated areas due to lockdowns. 4, mobility limitations and costs. All these highly affect the availability of fresh water for individuals. We start thinking out of the box, and our group found that thinking out of the box doesn't mean we go for bigger facilities. Actually, we had the other way. We will go small, and we will not only go small, we will go micro. And this is why we created our chip, microfluidic chip, for desalination of seawater and for purification. In this chip, we have 2 sections. The first section for water desalination and the second section of water purification. In here, the first novelty is that we are dissolving water. We are not dissolving salt. We are dissolving water. You're using organic phase, food grade organic phase. Second, we don't use membrane. Desalination without membrane, that means the power consumption is very low. The third one, purification using human hair visible light. This is the third novel point, where we have taken human hair and we treat it and we insert it in the second section, so it will start working for purification with visible light. So the challenges we faced is power consumption, size, efficiency, cost. And how we solve it? The power consumption by removing the membrane. So we have invented a new technology that not using membrane. The size was the micro size. We have microchips. You can handle it and carry it in your pocket. The efficiency, the micro mixing and micro separation in the microfluidic chip can give you huge mass transfer area for maximum efficiency, and the cost is very low because the fabrication cost of the microchip is very low. So this is what we are aiming for. We are aiming to have this microfluidic chip as part of every life vest in army, in airplanes, in marine, and everywhere. And for domestic use, we want to insert it as part of the drinking bottle, where you can put your seawater or underground water here, and using your human sucking power in order to push the water into the chip, and you will have a desalinated water that you can drink from there. This is the human hair part, where you can see here the human hair before treatment and after treatment, where we created a hollow fiber from it, and we use the melanin layer that is surrounding human hair as a base for to be a catalyst that can work in visible light. Most of the catalysts for water treatment work in UV light, but that another additional novel point where it works in visible light. So this is the setup, how it looked like, and this is a picture of the setup, a world-class lab for microfluidic we have in Carif, UNP. And here is how the separation in the capillaries happen, where the major droplets are generated, and the separation of the brain and the organic material is done by the microcapillaries. So the impact, we have three major impacts. First, the new chip is a need for every emergency kit, as we said in here. The portable kit can be developed and fabricated for personal use, and this is the main target, that every person can do his own desalination kit, or he can have his own desalination kit. The new proposed technology will create a new industrial line where the fabrication of each kit with its parts is complete industrial process by itself. So we are creating a new industry line. These are some of the results where you can see that using our microchip can reduce the water salinity down to 0.05%, which is very low. We have published our work in high-profile journals like the Scientific Report by Nature and by Chemical Engineering and Technology in Wiley. Thank you very much. I hope you enjoy our presentation.